All right, so we want to use our rules of cross product to prove this identity, I guess, over here. So we have two vectors A and B, and we want to know subtraction multiplied by the addition of the vectors is going to equal to 2 times the multiplication. And when I say multiplication, I mean cross products over here. So we know that these vectors are going to be in 3 space. So let me assume that A is going to be A1, A2, and A3. Let me represent that for the X, Y, Z component. And the same thing for B. So B equals to B1, B2, and B3. So let me rewrite this equation here using A1, A2, A3, and B1, B2, B3. I'm only going to work with the left side for now. So my X component is going to be A1 minus B1 because I have A minus B here. My Y component is going to be A2 minus B2. My Z component is going to be A3 minus B3. Then I'm cross multiplying this with the addition vector here. So my X component is just A1 plus B1. My Y component is A2 plus B2, and my Z component is A3 plus B3. So I want to cross multiply these two vectors over here. Now, there's a couple of different ways to do cross multiplication, but I personally like to just write the vectors above each other. I'll write this one below this one. And this may not be the easiest way to cross multiply. I know there's easier ways, but this is just the way I learned it. And as long as you cross multiply, you know your rules, you should get the same solution as me. I'm going to start with my X component for my cross multiplication. My X component, I'm going to hide this column and I'm going to cross multiply over here. So I have A2 minus B2 times A3 plus B3 minus A2 plus B2 times A3 minus B3. All I did was cross multiply like that and subtract. So now I can expand this out with FOIL. Remember, this is my X component. So I'm going to FOIL out these two brackets over here. So I'll have A2, A3 plus A2, B3 minus A3, B2 minus B2, B3. I always write the A terms first and then the B terms last to make things a bit easier. Then over here, I'm going to FOIL out these two and I'm going to keep it in a bracket because I have to distribute this sign later. So I have A2 times A3, which is A2, A3 minus A2, B3 plus A3, B2 minus B2, B3. And finally, I'll distribute this negative and I'll combine like terms, but I'll do it all in one step to make this problem more efficient. Otherwise, the problem's going to take a lot of space. You might not even complete it. So A2, A3 minus A2, A3, these two will cancel. A2, B3 minus negative A2, B3, that's A2, B3 plus A2, B3, which is 2A2, B3. Negative A3B2 minus A3B2 is negative 2A3B2. Then negative B2B3 minus negative B2B3, that becomes a plus. So these two will cancel. So this is my X component here of the cross multiplication. Now I simply have to do the same thing for my Y and my Z component. So for my Y component, I hide the middle column and I cross multiply like that. But just remember for the Y component, there's always going to be a negative. Again, that's the method that I use for cross multiplication. Whatever method you use, you should end with the same answer. So let's cross multiply these two. I'm going to hide the middle column. So I have this times this minus this times that. So A1 minus B1 times A3 plus B3 minus A1 plus B1 times A3 minus B3. Same idea now, you want to FOIL out the brackets. So over here, I'll get A1, A3 plus A1, B3 minus A3, B1 minus B1, B3. And over here, I'll get A1, A3 minus A1, B3 plus A3, B1 minus B1, B3. Close this. So now again, I'll combine like terms and I'll distribute this negative in the same step. A1, A3 minus A1, A3, these two cancel. A1, B3 minus negative A1, B3 is 2A1, B3. And then negative, negative. So this is going to become negative 2A3, B1. And then the last term should cancel off. They basically follow the pattern as they did in the previous one. So then just remember to distribute this negative into this bracket. So I have negative 2A1, B3 plus 2A3, B1. Okay, we're going to follow the same pattern for the Z component, but you can probably tell the answer without doing all the steps because you can see these follow the same pattern. So you should have the same idea, but I'll do the long steps to prove it. So for my Z component, I hide the Z column and I cross multiply this times this minus that times that. So I have A1 minus B1 times A2 plus B2 minus A1 plus B1, A2 minus B2. Steps are exactly the same. Solution will look very similar. A1, A2 plus A1, B2 minus A2, B1 minus B1, B2 minus bracket for all these out. A1, A2 minus A1, B2 plus A2, B1 minus B1, B2. Again, same things cancel. A1, A2, and A1, A2 are going to cancel. A1, B2 plus A1, B2 because of the double negatives is 2A1, B2. And then this and this will be negative 2A2, B1. And then the last one is going to be canceled. So here is my Z component right over here. Now that I found my X, Y, and Z components, I just have to prove that it's the same as 2 times A cross B. I have A and B over here. I just have to cross multiply these two. I'll do them at the bottom over here. A1, A2, A3, and then I'm cross multiplying it with B1, B2, B3. So this is pretty simple. It's the same cross multiplication. I just cross multiply these two. So my X component is going to be A2, B3 minus A3, B1. And if we look at it, A2, B3 minus A3, oops, not B1, B2. Just cross multiply like that. For my Y component, I just put a negative and then in a bracket, I'll hide the middle column. So I have A1, B3 minus A3, B1. I can distribute the negative into the bracket. So negative A1, B3 plus A3, B1. And then my Z component, I just hide the last column and I cross multiply. So I have A1, B2 minus A2, B1. Okay, now all I have to do is multiply these by 2 because my proof is to multiply these by 2. So if I multiply all of these by 2, you'll notice that the components will be exactly the same. The new x component of the right side here is going to be 2a2b3 minus 2a3b2, and now this is going to match this solution exactly. Same thing with the y component. If I multiply it by 2, I have negative 2a1b3 plus 2a3b1, which again matches this identically. And then the last z component, if I multiply by 2, we'll have 2a1b2 minus 2a2b1, which again matches this one exactly. And then we've done this proof over here.